All right. Part 2, binomial distribution. How in the world does the Pascal's theorem, or Pascal's expansion, binomial expansion, wind up helping us understand another type of distribution? So last class, you guys talked about how a probability distribution just means that you're looking at all possible outcomes. So when you guys see the word binomial, we always think of 2. And a binomial distribution is an experiment where you have repetitions, you have trials, they're all independent of each other, but you only have 2 possible outcomes. So very easy to see the connection with the binomial expansion, as you have 2 terms in a binomial expression, and we are going to have 2 possible outcomes in our probability distribution. So we are going to be talking about successes as the event is occurring, whatever we want the event to be, and a failure, which means it does not occur. Those are your only 2 options. For example, tossing a coin would be a great binomial distribution. You either get a head or you don't get a head, or you get a tail or you don't get a tail. So we could consider a head to be a success and a tail to be a failure, just depending on what you want to look for. So we are going to be talking about the probability of success as being represented by P. Probability of a failure will represent as Q, which is really going to be 1 minus P, since 1 is our 100%, all possible outcomes. And then remember a binomial distribution, the word distribution, that means that if I take P plus Q, I should be able to get 100% or 1. And also, if I look at P and Q separately, right, they have to be between 0 and 1. So the same rules apply to a binomial distribution as apply to any other distribution that we're looking at, any other probability distribution. So we're going to go through this relatively quickly, and we'll do more examples in class. But we're just going to take a look here at a spinner. It has 4 sides. They're equal. We're not weighting one side more than another. And you have 3 blue edges for the spinner, and you have 1 white edge. So out of 4, you are already recognizing that the probability of a blue side landing is 3/4, where the probability of a white side landing is 1/4. All right? 2 possible outcomes. P is a success. We're going to say that a success is getting a blue. So we're actually naming our blue to be the success. Again, that's just because of the way we want to set up this experiment. You guys could choose a totally different way to set this up, or you could be looking at a different color. So that means getting a white or not getting a blue is going to be our failure. All right? So what's happening here is if we spin the spinner 3 times, we are going to wind up wanting to get a blue 0 times to start. So we're saying that X is our random variable that we're looking at, and we're going to say that is when a blue actually occurs. So our probability of getting a blue, again, if we look back, it's 3/4. So I'm going to take 3/4. I do not want any blues to occur in this first possible outcome. So I'm going to want 0 blues, and that means I want my failure, which is 1/4, I want that to happen all 3 times that I spin the spinner. So since I'm spinning it 3 times, I want 3 of them to be a failure and none of them to be a success. That would be probability of 0 as my blue. So if I set this up for 1 blue, similarly, I'm going to want my 3/4 to be occurring once, which means I want my failures to occur twice, right? The only difference that starts to happen is that we notice that if I have 1 success and I'm spinning the spinner 3 times, that means I could have gotten a blue and then a white and a white, or I could have spun a white and then a blue and then a white, or I could have spun white, white, blue. So what we start to notice is that there are different ways that I could have gotten my success, my 3/4, right? My probability of getting the blue. So what we start to realize is that we have a combination of 3 spins, and one of them is my success. 3 choose 1 means that I'm going to wind up having 3 possible ways of setting this up. If we think back to the probability of 0 successes, That was 3 spins, 0, right? If I choose 0 out of 3, there's only one way for that to happen. So the order didn't matter here because all of them were going to be a failure. I wasn't going to have any successes. So let's look at 2. Probability of getting 2 successes would be the combination of 3 choose 2, which is again 3 different ways. And this time I want my successes to be 2, and I would only want 1 failure in this case if I spin 3 times. Again, we're assuming we spin 3 times. And then if I have 3 successes, there's only one way for that to happen as well. So 3 choose 3 will give us 1. And then I want all of my successes to occur, and I want no failures to occur. All right? So very similar to how we were setting up some of our probability problems the other day, but this specifically is a way to set up only binomial, so only having 2 possible outcomes. So what this is really relating back to is your binomial expansion. This really looks very similar to the term of your binomial expansion. The only difference is that different numbers or different letters are being used. Your P is representing the probability of your success. Your Q is representing 1 minus P, which is the probability of your failure. N is still how many trials you have, really. So for N in our binomial expansion, it was your exponent. R is what term you're on. In this case, it is how many successes we have, right? And so I want my probability of a success to be done R times, and I want my failure to be N minus R. And that will help us figure out whatever we are looking for, depending on the experiment. We are going to be using this a lot when we see you guys next class. All right? Have a good night.